We are the genuinely android life in the known universe. I mean, imagine that we're the key place where there is information in this limitless framework. Cosmologists, by and large, all throughout the world are in wonderment of this unendingly pushing discovery. The James Webb Space Telescope has gotten the unpretentious sparkle of city lights, an unfathomable 7 trillion miles from Earth, beating all inquiries. This shocking achievement accomplishes something other than extending our perspectives to the extent of what we are and the universe. The speculation goes wild as analysts pore over the data, searching for signs that could open the insider secrets of these confounding, stunning guides. The contemplations are surprising. Really investigate that we are going on in the means of several extraordinary individuals in the universe, that the universe is spilling done with life and improvement unimaginably far outside our capacity to comprehend. Is it possible that these far-off lights show the presence of extraterrestrial social orders? What's the significance for our knowledge into the likelihood of life in the universe beyond Earth? Go along with us as we check how out the James Webb Telescope as of late saw city lights 7 trillion miles away. Sent off into space on Christmas Day 2021, the James Webb Space Telescope was expected to beat the altogether respected Hubble telescope in capturing astoundingly sharp photos of recently found awe-inspiring things, planetary designs, and more. An irrefutable objective of the JWST is to center around the advancement of the earliest universes by looking at the far-off bordering occupants of the universe. This is helpful considering the truth that the journey time of light all through our universe is billions of years. When the JWST gathers light, it gets these items precisely as they were billions of years ago. Space specialists measure distances in light years, which is the distance light can go in a year. To frame this reality, the mission's largest practical undertaking was a massive field picture that was presented on July 11, 2022, by U.S. President Joseph Biden while he was talking from the White House. While the Hubble Space Telescope focused on a solitary district of the sky for 10 straight days, starting on December 18, 1995, the Hubble Deep Field got omnipresence. The region was only a small spot, making up around 1/1,000,000th of the entire sky. Most of the 3,000 currently substantial things found by Hubble were immense frameworks, followed down billions of light-years away, with its thought on the SMX 0723 framework bunch. The JWST Deep Field covers a correspondingly small sky district. The framework plan SMX 0723 is 4.6 billion light-years away, and the more far-off universes behind it are enhanced by the supergravitational field. The supporting of the wonderful systems is bowed into titanic turns, where the gravitational field is generally serious. In one case, it was affirmed that it took a distant world's light 1.1 billion years to arrive at the telescope, coming about because of going through space. The light being conveyed extends as the universe turns into the primary objective of the JWST. The JWST has been to catch apparent light from their stars into the infrared. Astronomers can obviously see JWST also apparent light photos of contiguous universes taken by Hubble and different telescopes. By collecting information at those frequencies, we can perceive how systems have developed over a monstrous timescale and joined into the shapes we notice today. More shocking than the sheer number of plans in the JWST first deep field picture is how rapidly it was caught in only hours, compared to days or even months for other telescopes. Anywhere it looks, it can't stay away from the inspiration to track down universes. Universe social gatherings aren't the only objects going about as improving principal issues. Well-informed authorities used the JWST to get an image of a few systems designated VV1191, so they could shine on how the light from one of the pair changed as it went through the other. The later effects of this study will uncover the properties of the intervening world's progression. Also, evidently, the JWST may have really made a fantastic discovery. Light from an extraordinarily far-away system, the announcement of the possible presence of auroras on an exoplanet, came from the official JWST site. The shortage of a host star and the chilly temperature make it awkward to pinpoint where the energy in the upper air is coming from. Regardless, the way that the object showing auroras is without a doubt creating methane is a fundamental point. Of course, like auroras on Earth, they are caused when overflowing particles going from the sun into space are gotten by our planet's attractive field. The charged particles then advance through Earth's air near the poles, where they slam against gas particles, making a splendid light show called the aurora borealis. Jupiter and Saturn have comparable auroral anomalies in view of the sunlight-based breeze. In any event, common W11 1935 has no star to circle, so its auroras are an enormous secret. Everybody's inquiry keeps on zeroing in on Proxima Centauri TRAPPIST-1, around 4.4 light-years from Earth. Inside the Milky Way galaxy, specialists have recognized the presence of water on the exoplanet, and the believability of life on the world can't be hindered. Are we finally going to see verification of life beyond Earth? Just last month, the JWST saw another remarkably colossal black hole. This giant black hole was seen in different frequencies and is consuming everything around it. This revelation is 40 million times as wide as the Sun. But what's the best significance for us? The JWST has seen that this unimaginably enormous black hole has been present since the start of the universe. Probably it won't move. This monster is quickly consuming everything in its close-by area. The discovery was made by Dr. Lucas Fu and Professor Alastair Z of the Ben Gurion University of the Negev in Israel. According to their disclosures, the extremely tremendous black hole is practically on various occasions heavier than the Sun, making it an immense substance. Luckily, it has been found at a giant range from Earth, around 129 billion light-years away. Still, it is moving closer, with the black hole consuming everything around it at a fast rate, as shown by the red shift. When the JWST started sending back its limited information, inspectors were stimulated as they separated through the data. They immediately accepted it was a close-by tremendous black hole. When they inspected the information using gravitational lensing, they tracked down something significantly more fascinating. The discovery of similar peculiarities in other early universe very enormous black holes has given new insights into the advancement of both the black hole and its host galaxy, as well as the association between the two. This is still generally obscure, but it might be proof of the beginning phase improvement of gigantic objects like star-forming materials that fell into black holes. Space scientists can't yet see precisely what's going on in the photos sent back to Earth, but one thing is clear. The James Webb Space Telescope is continually finding new odd objects. Consistently, we have the delight of investigating space and being captivated by the amazing lights of planets and stars that float across the universe light-years away. Given the flood of far-off, overstated structures uncovered by the Webb, there is a consistent surge of new inconsistent ordering. Everybody's eyes are focusing in on a specific plan of Earth-sized planets that could hold the key to finding extraterrestrial life. The individual driving forward inconvenience, which includes the shortage of verification for high-level extraterrestrial life in the universe, not getting through the high probability that such substances exist, could finally be settled. Where are these planets? They sit exactly 40 light-years from Earth. Additionally, the close-by star framework is known as TRAPPIST-1, which has 7 planets circumnavigating it. In their journey to track down legitimate planets, NASA is considering a wide grouping of standards beyond the planet's size and distance from its star. A more sensible philosophy is to assess the general conditions of the planet's environment, as this would permit examiners to decide if the planet is decent. The Infrared Spitzer Space Telescope, which is part of NASA's space exploration mission, uncovered the 7 merciless exoplanets orbiting a similar star, TRAPPIST, quite a while ago. The James Webb Space Telescope has now measured the temperature of TRAPPIST-1b, one of those planets. The JWST has consistently made critical disclosures since its launch. Furthermore, this finding is simply the most recent in a progression of record-breaking firsts. This is the primary revelation of light created by an exoplanet as small and cool as those in our own close-by planetary gathering. No other telescopes have been able to measure such weak mid-infrared light. Space scientists were energized when they first learned about the 7 TRAPPIST-1 exoplanets, as these faraway universes are all Earth-sized and remain in the habitable zone, the area where planets can have fluid water on their surfaces. Anyway, TRAPPIST-1 planets are beyond our current reach, considered an astounding 235 trillion miles away. They circle a star a lot smaller and redder than our Sun, known as an M-dwarf star. These stars are far more common in the Milky Way than Sun-like stars and are ideal targets for planet trackers. M-dwarfs are also more likely to shoot and send high-energy radiation, which could hurt emerging extraterrestrial life or a planet's atmosphere. When we turn our regard for TRAPPIST-1b, we find that it is perfectly locked to its star. One side of the planet is continually facing the star, while the other remains in eternal darkness. This difference in temperature creates extreme conditions, with the daytime side reaching temperatures hot enough to melt iron. The dark side remains much cooler, but warm enough to prevent the development of methane, a critical atmospheric gas. Despite the fact that this could reduce the planet's genuine potential for hosting life, the JWST's ability to measure these limiting conditions offers a novel perspective on distant exoplanets and their environments. Researchers are especially intrigued by TRAPPIST-1 because it has the potential to open the secrets of how planets in far-off star systems could develop and support life. The system's planets are all Earth-sized and sit within the livable zone, meaning they are at a distance from their star where liquid water could exist on their surfaces, a fundamental element for life as we understand it. The discovery of such circumstances on exoplanets is exciting because it brings us one step closer to understanding whether life exists somewhere else in the universe. By using the James Webb Space Telescope to measure the composition and temperature of exoplanet atmospheres, scientists can search for signs of life-supporting conditions. The ability to detect atmospheric components such as water vapor, methane, and oxygen could offer clues about whether a planet may harbor life. The JWST discoveries are still in their early stages, but each new piece of data brings us closer to answering the mysteries of the universe, including the possibility of extraterrestrial life. As the telescope continues to send back extraordinary pictures and information, it is expected to alter how we might understand space, the origins of the universe, and the potential for life beyond Earth. In summary, the James Webb Space Telescope is not just expanding our knowledge of the universe, but also inspiring new questions about the potential for life elsewhere in the universe. With every breakthrough discovery, we draw closer to answering one of humankind's greatest questions. Are we alone in the universe? The James Webb Space Telescope, JWST, has fundamentally changed our understanding of the universe, uncovering secrets that were once beyond our reach. This wonderful piece of technology not only allows us to peer deep into the universe, but also has the potential to answer one of mankind's most significant questions. Are we alone in the universe? The JWST's ability to observe distant galaxies, exoplanets, and cosmic phenomena has already begun to yield shocking insights. As we continue to explore the far-off reaches of space, the JWST is enhancing how we understand the formation and evolution of galaxies. It can observe systems that formed only a few hundred million years after the Big Bang, revealing the early stages of cosmic development. This understanding is crucial for grasping how galaxies and star systems came together to create the structures we see today. By studying the evolution of these distant galaxies, scientists can better understand the processes that led to the formation of stars, black holes, and planetary systems. Perhaps one of the most exciting aspects of the JWST mission is its ability to study exoplanets and their atmospheres. The telescope's infrared capabilities allow it to detect subtle signs of chemical composition in the atmospheres of exoplanets, even in distant systems. This could provide crucial information about whether these exoplanets could support life. The ability to detect water vapor, carbon dioxide, methane, and other molecules associated with life is a game-changer. Researchers are particularly focused on exoplanets in the habitable zone of their stars, where conditions are just right for liquid water to exist. In addition to the study of exoplanets, the JWST has also provided new insights into the behavior of black holes. As scientists continue to study supermassive black holes, the JWST's ability to capture detailed images and spectra from these objects is helping to unlock the mysteries of their formation and evolution. These black holes are thought to play a crucial role in the development of galaxies, influencing their structure and growth. By studying these enormous monsters, scientists are gaining a deeper understanding of how the universe works on a grand scale. Another fascinating part of the JWST's work is its investigation of stellar nurseries, regions where new stars are born. These nurseries are often obscured by thick clouds of gas and dust, making them difficult to study with traditional optical telescopes. However, the JWST's infrared sensors can penetrate these clouds, revealing the secret processes that give birth to new stars and planetary systems. This research could provide valuable insights into the conditions necessary for life to form elsewhere in the universe.